A very good day to my lecturer, Dr. Yoh Chio Kiat. My name is Muhammad Najmi bin Nordin. My metric number is 211-72873. I am from Polymer Engineering and this is my YouTube presentation for quality control subject, which is raw data for 3 machines used to produce a component for a phone. This is the main point that I will discuss during the presentation. This is the introduction part. The 3 machines used to produce a component for a phone. Length specification for the component is 50 mm plus minus 5 mm. The maximum measured electrical resistance should be 10 ohm and the constant value is pressure and temperature. For pressure, it is 200 kilopascal and for temperature, it is 338 Kelvin. Now we move to the control chart part. Control chart is a statistical tool used to monitor and analyze process variation over time. It helps determine whether a process is operating within expected limit or it has gone out of control. Control charts are widely used in quality management and process improvement methodologies such as Six Sigma. This is the X bar 1 chart for machine 1 and from this graph, this is the information that we get. The center is 49.99308. The standard deviation is 0.5121261. The lower control limit is 48.4567 and the upper control limit is 51.52945. For machine 2, the center is 51.22302. The standard deviation is 0.9056306. The lower control limit is 48.50613 and the upper control limit is 53.93991. And this is for machine 3. The center is 51.38204. The standard deviation is 0.9014743. The lower control limit is 47.67762 and the upper control limit is 53.08646. And if we see from this X bar 1 chart, this is the outlier for the machine 3. Next, we move to the process capability part. Process capability is an analysis that helps organizations to understand whether their processes are capable of meeting customer requirements. It enables them to make data-driven decisions to improve process, reduce variation, and enhance product service quality. By focusing on process capability, organizations can strive for continuous improvement, reduce defect, and enhance customer satisfaction. This is the data for machine 1. For process capability, the value that we highlight is the CP value and CPK value. The CP value for machine 1 is 3.25 and the CPK value also 3.25. The CPK value is greater than 1.33, so it shows that machine 1 is capable. For machine 2, the CP value is 1.84 and the CPK value is 1.39. The CPK value also bigger than 1.33. It shows that machine 2 is capable. And for machine 3, the CP value is 1.85 and the CPK value is 1.71. CPK value also bigger than 1.33 and it shows that this machine 3 is also capable. Next, we move to the comparison part. For this comparison part, we use box plot. Boxplot provide a concise visual summary of the distribution of dataset. They display important statistics such as median, quartile, and any potential outliers. By comparing multiple boxplots side by side, you can quickly assess the difference in the central tendency, spread, and skewness of different datasets. This boxplot shows the comparison of three machines. The center of distribution for machine 3 is the lowest among the three machines. If we see the box plot, all the machine has almost symmetrical skewness, but machine 2 has the widest spread among the other machine. Machine 1 and machine 2 has outlier. For machine 1, it has two outliers, and for machine 2, it has only one outliers. The last one, which is machine 3, it has no outlier at all. Next, the statistical analysis. In this analysis, we use this coding, the red one. In this part, we focus on the PRF value. The PRF value must lower than 0.05. If we see here, the temperature value is 2 exponents negative 16. So, for machine 1, only temperature has significant effect on part resistance. As for machine 2, also the PRF value only for temperature, it has the value of 2 exponent negative 16. So it shows that only temperature has significant effect on part resistance as the value is lower than 0.05. In machine 3, if we refer at the PRF value, also the temperature value is lower than 0.05. So we can conclude that for machine 3, only temperature has significant effect on part resistance. Next is the recommendation part. For machine 1, it is stable due to no outlier at lower control limit or upper control limit. It is capable because the CPK value is 3.25, which is more than 1.33. Machine 2. Machine 2 is stable due to no outlier at lower control limit or upper control limit. It is capable because the CPK value is 1.39, which is also more than 1.33. And the last machine, the machine 3, is not stable due to one value is beyond the upper control limit. It is capable because the CPK value is 1.71, which is bigger than 1.33. My recommendation, based on the observation at CPK value and control chart diagram, it shows that machine 1 and 2 is the best machines to use for production as it have no outliers. At the same time, it has the high CPK value. The CPK value, the bigger the CPK value, the better for the machine to be used in production. For machine 3 that has an outlier, I would suggest to make some regular maintenance for the machine to make sure it can achieve a persistent product quality. Then, the machine also need to be used according to its capability and manufacturer's guideline to avoid it from overworking that may damage the machine. I think that's all for my presentation. Thank you.